Hello and welcome back to Chopstick Maths Differential Equation Exercise 8 Sum number 9. We have to find the solution of this given differential equation d square plus 4d plus 4 into y is x square. Now the general form of such a differential equation is f of d into y is equal to x raised to m, where f of d is d square plus 4d plus 4 and x raised to m, where m is any positive integer, therefore x raised to m is x square. Now the solution for such a differential equation is equal to y is equal to complementary function cf plus the particular integral pi. That is the solution of this differential equation has two parts, cf and the pi. So let us first calculate what is the cf. Now to find the cf, we have to equate f of d is equal to 0. So d square plus 4d plus 4 is equal to 0. Now here you can see this is a simple quadratic algebraic equation and you can solve this by factorizing d plus 2 into d plus 2 is equal to 0. Therefore, the roots of this differential equation are d is equal to minus 2 comma minus 2. The equation, which is also called as the auxiliary equation, has two roots and they are minus 2 comma minus 2. That is, they are rational and they are repeated. So CF will be equal to C1 plus C2x into e raised to minus 2x. And C1 and C2 here are some arbitrary constants. Now let us find what is the particular integral pi. Now, the pi for such a differential equation, the formula is pi is equal to 1 upon f of d into x raised to m. So pi is equal to 1 upon d square plus 4d plus 4 into x square. Now, here you have to express f of d as 1 plus phi of d, where phi of d is some other function of d. So pi will be equal to 1 upon 1 plus phi of d into x raised to m. So now let us proceed to express f of d as 1 plus phi of d. So d square plus 4d plus 4. Now to get 1 over here, we'll have to reverse the order, that is we'll have to get 4. So we'll reverse the order of this particular expression. This will be 4 plus 4d plus d square. Now to get 1 over here, we have to multiply and divide this by 4. So this will be equal to 4 into bracket 4 plus 4d plus d square upon 4. So this will be 4 into bracket 4 plus bracket 4d plus d square the whole upon 4. And this can be written as 4 into bracket 4 upon 4 plus 4d plus d square upon 4. Now this will be equal to 4 into bracket 4 and 4 will cancel, 1 plus 4d plus d square upon 4. Now you can see this is of the type 1 plus phi of d, where phi of d is 4d plus d square upon 4. So let us substitute this here. So pi will be 1 upon 4 into bracket 1 plus 4d plus d square upon 4 into x square. Now we can get this in the numerator. So pi will be equal to 1 upon 4 into 1 plus 4d plus d square upon 4 the whole raised to minus 1 into x square. Now if you see here, we'll have to expand this particular term which has an exponent minus 1. And this can be done with the help of this formula. 1 plus bracket the whole raised to minus 1 is 1 minus bracket plus bracket square minus bracket cube and so on. Now here if you look, 1 plus bracket here is 4d plus d square upon 4. So applying this formula for this particular expansion, we get pi is equal to 1 by 4 into bracket 1 minus bracket, that is minus 4 plus minus 4d plus d square upon 4 plus bracket square, that is plus 4d plus d square upon 4 the whole square, and we will neglect the higher powers into x square. So pi will be equal to 1 by 4 into bracket 1, we'll open this bracket, minus 4d upon 4 minus d square upon 4 plus, we will expand this particular bracket using a plus b the whole square. This will be 16d square plus 8d cube plus d raised to 4 upon 4 square is 16 into x square. This will be pi is equal to 1 upon 4 into 1 minus 4d upon 4 minus d square upon 4 plus 16d square upon 16. Now here again we will neglect the higher powers of d. That is d raised to 3, d raised to 4 will neglect because d is the differential. Okay, that is d is the first order derivative, d square is the second order derivative, d cube is the third order derivative, and so on. Now here the first order derivative of x square is 2x. The second order derivative of x square will be 2. And the third and the fourth order derivative will be 0. And so we can neglect d cube and d raised to 4. So this will be pi is equal to 1 upon 4 into bracket 1 minus 4d upon 4 minus d square upon 4 plus 16d square upon 16 into x square. So that will be equal to pi is equal to 1 upon 4 into 1 minus 4 would cancel. So this will be 1 minus d square upon 4. Here 16 would cancel. So this will be plus d square into x square. So this would be pi is equal to 1 by 4 into bracket 1 minus d, and adding these two like terms we get plus 3d square upon 4 into x square. Now on multiplying we'll get pi is equal to 1 by 4 into bracket 1 into x square is x square minus d into x square is minus dx square plus 3d square upon 4 into x square is 3d square upon 4 into x square. This would be pi is equal to 1 upon 4 into bracket x square. Now d of x square means the first order derivative of x square will be 2x, so this will be minus 2x plus 3 by 4 into d square. X square means the second order derivative of x square, which is 2. So this will be 3 by 4 into 2. So this would be pi is equal to 1 by 4 into bracket x square minus 2x plus 3 by 2. So this is the particular integral of the differential equation. So the complete solution now will be y is equal to cf plus pi. That is, cf is this, y is equal to c1 plus c2x into e raised to minus 2x plus pi is 1 by 4 into bracket x square minus 2x plus 3 by 2, which is the complete solution of the differential equation. Thank you very much.